Okay, all right, let's move on to solving equations that involve radicals. Okay, and these are a little bit different than maybe what you've seen in the past. So let's look at a problem like this. The one thing you want to keep in mind, well, two things you want to keep in mind. We want to isolate the radical. Okay, we want to get the radical by itself because if you take just a very simple, let's take a very simple radical equation just off to the side here. If I had something that looked like this, and I said, solve for x, right? We'd want to get this by itself. We'd subtract the 1 from both sides. And then we'd want to square both sides, right? Because squaring is the inverse operation of square rooting. So we'd take that and we'd take the square root of x and we'd square it. And then we'd take 6 and square it. And then we'd get our x equals 36, right? So one thing you want to keep in mind here is when we solve these equations, some crazy things might happen, okay? And you're going to want to check whatever value you get for x back in here, okay? So hopefully my device will hang on here for the last couple of minutes. When we solve for x, whatever we get for x, we're going to want to check it to make sure we're not having to take the square root of a negative number here, right? Which would not result in real number solutions. So we'll cross that bridge when we get to it. The one thing, though, that you're going to find in common here is get the radical by itself. Isolate the radical first, then square it, then we're left with just x. In this case, we're going to isolate this radical. So a couple of things we can do here. I think what we want to do is this x clearly shouldn't be over here, right? We can move the x over here, but I really want my radical to be positive. And when you consider a radical as a grouping symbol, okay, what I'm going to do, this may seem a little unconventional, but I'm going to add this entire expression to both sides of the equation, okay? So I'm adding radical 2x plus 7 over to the other side. That's going to ensure that my radical is positive. So now I have 4 plus the square root of 2x plus 7. There are other ways to do it. I could have left it over here, but then it would have been a negative, and then I'm dividing by a negative, and then or multiplying by a negative and having to worry about changing two signs. I'm going to try to avoid that. Okay, so I add this. I add the entire radical because radical is a grouping symbol. So everything that's under here goes with the radical when I add it to the other side. Now I'm going to try to isolate this, right? Which means I need to get rid of this 4 that's over here. So I have to subtract 4 from both sides. So I end up with x minus 4 equals, that's Evelyn if you can hear her giggling in the background, the square root of 2x plus 7. Now I have my radical isolated. And just like I did here, what did I do once I had the radical isolated? I squared both sides because that gets rid of that radical symbol. I'm going to do the same thing here. So once we get to this space, I want to square this to get rid of this radical symbol. But whatever I do to one side, I have to do the other, which means I'm squaring this, and I'm squaring everything that's over here. So this is where things get a little crazy, right? Because we're squaring this binomial. So I'm just going to write that one more time as x, the quantity x minus 4 being squared, and that's equal to now 2x plus 7. And so we have the makings of a quadratic equation. Now, in terms of solving a quadratic equation, take your pick, okay? I think what makes the most sense here is let's expand this so that I don't have this squared binomial, okay? And then when we solve a quadratic equation, we have to move all the variables or all the values to one side and set it equal to 0. So I'm going to square this real quick, okay? And on your own, what is x minus 4 squared? It's x minus 4 times x minus 4, which when you expand that becomes x squared minus 8x plus 16, and that's equal to 2x plus 7. Now I'm going to move the 2x over, and I'm going to move the 7 over by using inverse operations. So I'm going to subtract 2x, and I'm going to subtract 7 at the same time, because both of those terms are going to have to come over here. The 2x gets subtracted from the x term, the 7 gets subtracted from that floating constant, so we have x squared minus 10x plus 9 equals 0. Now again, you have your choice. You've got your quadratic, it's set equal to 0. Do you want to use the quadratic formula for this? Do you want to graph this? If you've done any work with solving quadratics, when you graph a quadratic equation, the x-intercepts are the solutions. Do you want to factor this? It's totally up to you. Because we're probably doing this for an Algebra 2 or a pre-calculus class, let's factor. Let's see if we can factor this quadratic or even degree trinomial. I know that I have to have an x here and an x here in the start. I need two numbers that multiply to be positive 9, but add to be negative 10. So I can't have positive numbers in these spaces because they would not add to be negative 10. But two negative numbers will multiply to be a positive and add to be a negative. So those two numbers are negative 9 and negative 1, right? Now, each one of these, because we have the zero product property, I know that x minus 9 could equal 0, and I know that x minus 1 could equal 0. So we're getting x equals 1, and we're getting x equals 9. Now, here's the thing that people tend to forget once we get to the end of this problem. So those are our two solutions, right? Come back up here. All right, I'll write it in a different color. So we're at this point, we're saying x could equal 9 or x could equal 1. If I take the number 9 as my solution and I plug it in here, 2 times 9 is 18, 18 plus 7 is 25. This becomes the square root of 25, okay? 9, right? 9 minus the square root of 25 is 5. 9 minus 5, that's 4, okay? Bingo. If I take the number 1 and I put it here, 2 times 1 is 2 plus 7, that's 9. The square root of 9 is 3, right? So I get 1 minus, is 1 minus 3 equal to 4? Okay, no, but sometimes the square roots here can be negative, right? So the square root of 9 can also be negative 3. So it is possible that 1 and 9 are both solutions to this problem. The one thing when they say check all proposed solutions, what they're saying is, okay, make sure that whatever number you get as a solution, when you plug it in here, you're not having to take the square root of a negative number, right?